minus 3 times x minus 2. So I'm just going to clean this up a little bit and see what I'm working with. I don't know why it keeps. All right, x squared minus x equals minus 3x plus 6. Since I have a quadratic, I'm going to go everything on the same side and see what we do. Let me combine this first. X squared minus 3x equals negative 3x plus 18. Now add this to both sides, and they are going to cancel. Square is 18, and I can just square on both sides. Yeah. There we go. But I need to simplify that with 9 and 2, right? The square root. Did you? So plus or minus 3 root 2. Got it right. That is the first time I've done one right. Somebody must have taught you really well. That's all I know. Yeah. 50? I'm going to do 50 and then I'll do 51. I'll go in order. All right, 50. Oh, this is a good one. X plus 2 minus 2 times the square root of plus 3 equals 0. If I were doing this one, I would probably, and I'm trying to remember what we did, but we did algebra 2. I would get that radical by itself so that I could get rid of the radical. So I'm going to move everything except the radical. So I'm going to subtract. So I have negative 2 square root of x 3 equals x minus 2. And I'm going to divide everything by negative 2. Now, if you didn't want to do all this, it said some method you certainly could graph this and find, since it already equals 0, you could find where it crossed the x-axis, and that would be your solution. Up to you. When I divide this, I get the square root of x plus equals. I'm going to make 1/2 x plus 1. Say again. I wouldn't, because whenever you've got a radical there, you need to get rid of that radical so that you can work under it. At this point, looking at it, because I know, Adam, could we not play with our lanyard? What? At this point, I would look at this and say, you know what? If I square both sides, I'm going to be foiling out with a fraction, and it's going to get nasty fast. I would stop here and go, you know what? I think I'm going to graph. I think I'm going to graph this, and then graph this, and find where they intersect. And they're easy graphs if you put them on your calculator. 1, 2, 3. This one's negative 3, 0 starting point. And then it's going to go like this. This, of course, is a line, slope 1 over 2. It's going to look like this, and you can calculate that point of intersection. That point of intersection comes out to be, what number is this? 50? I don't know if I don't have my calculator. What'd y'all get? What is it? Is it the square root of x plus 3? And then the other equation was 1/2 x plus 1. 2.828. Yes, maybe so. Okie dokie, I have the attention of about a third of you, but that's okay because you have a test tomorrow, so you can show me that you were justified in doing everything except for paying attention. Shade. At least take it in a decimal place. That way we know.
It's like on some of the other ones like that, it was like 0.7, like, and it was like 2.9, and I just rounded it.
I mean, that's fine. I wouldn't, but if it's a decimal, that way we know it's. All right, which other one? 51. Let's see. Because 51 is a cubic, and the only method you would have for solving this in your toolbox of solving would be back to Algebra 2 where we found PRZs and we got it broke down so that we could factor it. Possible rational zero, where then we started synthetically dividing to see which one gave us a order of zero to then fully factor it. So, I wouldn't do that unless you're made to do that because it is a lot. If you're given the option, which you will be at this point, I would graph find the zeros for sure. You could try to slash it because it's 4 pieces. The problem with slashing here, if you slash it, you get x squared times x plus 4. Guys. So in order to slash it, boys, these would have to be exactly the same. So that would be, can't do that. So I'd have to graph this one. And actually, because the answers, looking at the answers, what they are, even if I did PRZs, it's not factorable. So graphing's your only option there. Do you need me to graph it and show you, or y'all good on that? Yeah, you could have, sure. You could have. Plug this on the calculator and it crosses the x-axis. Yep. Way too much. Yes, Khalil. This 2 goes to pieces, so x divided by 2 is the same thing as 1/2 x. What else? Yes, ma'am. 54. 54 is another one that I would not attempt to do algebraically because the way absolute values work, you set, if you're solving algebraically, you get the absolute value by itself, and this, you should have learned this in Algebra 1, but maybe you didn't because I heard several people say they didn't know how to solve algebraic, absolute value. But you isolate the absolute value, and then you see the positive into the negative, and you get the 2 answers. In this case, because they're both absolute value, it's going to be a little bit different. You're going to end up with something like this for the 2 of them. And so I'll graph them and find that intersection point again. And that intersection should add negative. What else? 55. Again. 55 is any of these without value, I would most definitely graph and find the solution. Rather than say positive and the negative, because what's going to happen here, this is an absolute that opens like this, and this one is a parabola, and let me think, 1/2 stretched out, and it's up 3, it's down 4. This should intersect in 2 places. Yeah. This one's just going to be down below it as a parabola, and so it's going to look like that. And these 2 places, which are negative 2.1 and 2.91, those are going to be your 2x intercept, 2 places where they intersect. I think y'all might have made it a lot harder than what it was. She could graph it. Okay. I'm sorry.
Yeah, I would have photographed like all of them.
Yes. Yes, where you'll have a method to do, yeah. You have a couple that say you can use any method you want, but most of them are going to be. All right, so today is review day because you have a test tomorrow. Yay! I don't have you a written review. I'm going to, like, I'm in a printed review. We're going to use the one out of the book, and all the answers are there for these. So if you give me just a second, I need to get. I keep thinking your books are going to be here, and so I don't.